are trying to figure out if the 3 side lengths I gave you are going to make a triangle or not. So can somebody remind me from yesterday, how are we going to mess with these numbers and figure out if these will make a triangle or not? What do we need to do? Yes, we're going to add the smaller sides together. And once we add them together, how are we going to tell if they work or not?
Because the number that you add up needs to be greater than the other number.
Yes, yes.
The bigger number.
Exactly. So we want to look at the 2 smaller sides. So in number 1, what 2 numbers should I add together?
2 and 3.
2 and 3.
Which is 5.
Perfect. 2 and 3 is 5. And is
5
5 greater than 6?
No.
No. So does number 1 make a triangle? Nope. It sure doesn't.
I just
Sure
put no, is that
doesn't.
okay?
That is perfect.
Okay.
Perfect. How about number 2? 5, 13, and 16. Which 2 should we add together? Yeah. 5 plus 13 makes what?
18.
18. Is 18 greater than 16? Yes. So this does make a triangle. Perfect. How about number 3? We got 27, 3, and 24. Which 2 should we add together? Good. 3 plus 24. What does that give us?
27.
Okay,
No,
so
it doesn't make it.
yeah, we got to ask ourselves, is 27 bigger than 27?
Nope.
It is not. It's equal to. So this also does not make a triangle. It's got to be greater than. It's got to be bigger. Okay, number 4. Which sides should we add together?
21 and 25. I mean, 21 and 23.
Yes, 21 and 23. What does that give us?
44.
44. Is 44 greater than 42?
Yes.
It is. So for number 4, we have yes, it does make a triangle. Perfect, guys. Do we have any questions about that process, or do we all feel okay about it?
I'm good on that.
Feel good?
Mhm.
Good. All right. Let's look at number 5. So for these last 2 questions, I had you find the missing side length for each of the triangles. These are right triangles. And we're using the Pythagorean theorem. We talked about that yesterday. That's where a squared plus b squared equals c squared. So which side always has to be c?
Longest one.
The longest one. The longest side is always going to be that diagonal that's directly across from the 90-degree angle. Any of you remember what this long diagonal is called? The hypotenuse. Good. I love that. Okay, so for number 5, how could we set up an equation to solve for c?
A squared plus b squared equals c squared.
Perfect. So what's my a squared? What number should I put for a?
6.
Yeah, 6. I want to put a is 6. So 6 squared.
And then b will be 6.
B is also 6. Perfect. So plus 6 squared. And what else do I need to write?
Equals c squared.
Perfect. Equals c squared. Okay, so where do I go from here?
Square one.
Yeah, we just want to square them. So remember, a number squared just means you're multiplying it by itself. So we're really just doing 6 times 6. What's 6 times 6? 36. We did the same thing here. 36 plus 36 equals, we don't know c yet, so it just stays c squared. Okay. What should we do next?
You have to add them together, and that's up to 72.
Yes, we're going to just add these 2 together. 36 plus 36 is 72. And we'll just bring down equals c squared. So when we're solving an equation, We're always using our inverse operations. Remember, if we're adding, we subtract. If we're multiplying, we divide. You guys remember what the opposite of squaring something is? Square root. Perfect. So we're just going to draw the square root symbol on both sides of our equation here. And by doing this, the square root of c squared, what happens? It cancels out. So now we have c by itself equals, how do we find the square root of 72? We can use our calculators. We totally can.
8.48.
What'd you say?
8.48.
8.48. I think you are correct. You are. Let's type it in just to show everybody. In case you forgot how to use the square root function, grab your calculator. And this is an important one. We use this a lot in here. We're going to hit the second button at the top left-hand corner. It's blue. And once you've pushed that, you'll go down and find the button right next to 7 that says x squared. Hit that button, and suddenly we have square root on our screen. Then you just have to type the number, which is 72. When we hit enter, we'll get that number that you just told us, 8.48. Now, if we were rounding, it would be 8.49, but I'm not going to be picky on that. You can put 8.48, you could put 8.4, 8.5.
At 5, if you round up, or if it's below, like I don't.
So if it's 5 or greater, we go up. If it's 4 or lower, we go down. So you're right on it. So our C is going to be 8. I'm just going to say 8.485. You don't have to write that many decimal places. But that's just what I'm going to put. So that's the answer to number 5. We found C. Do we have any questions about this process? And please don't feel like you're going to annoy me or frustrate me. If you need help, we just learned this yesterday. Let me know if this is a little confusing. I'm happy to go over it a little more slowly. I'm happy to give a little more detail. Anybody want me to go over this more?
No.
Okay, we feel okay? All right. Let's look at number 6 then. First, let's decide what is A, what is B, what is C. We already have A. What number?
A squared plus 14 squared equals 16 squared.
Yes, that is how we're going to set it up. So, looks like you decided 14 was B, and that is correct. 16 is C. So I'm going to write that equation you just gave me. A squared plus 14 squared equals 16 squared. Okay. So, what do we do next?
Bring the A squared down.
Bring it down where? What do you mean?
Like, first of all, you 14 and like you square that.
Yeah, we want to square these numbers first.
Yeah.
So let's do either 14 times 14, or we could just type 14. That's not 14. 14, and that same button for the square root, x squared. Hit enter. 196. Okay, so we found 14 squared. What else do we need to find?
16 squared.
Good. What's 16 squared?
256.
256. Okay, what do we need to do next? So we are going to be subtracting on both sides. I'm almost not there yet. Now this is the part where you were telling me, Alexis, we're going to bring down a squared plus, and then our equal. Now I'll do what you told me, Ritson. We are going to subtract 196 from both sides. Okay, and What is this going to give us?
60.
60. Perfect. We'll bring down our equal sign. And we still have a squared. So are we done? Did we figure out A? No.
You have
What
square
else?
root.
Yes, we need to get rid of that squared. So we take the square root of A squared and the square root of 60. So what happens to A squared?
They cancel each other out and then you get 7.74.
Yes, the squared and the square root cancel. We're just left with A. And then the square root of 60. Can you say those decimals one more time? It was 7.
7.74.
Perfect. 7.74. Beautiful. And that is our answer. Okay. Any questions about these?
Okay, we're done.
No, do nows are just participation, just that I saw that you were here and you worked on it. That's all that I'm looking for.
What's going on? What's my bad? What's going on?
All right.
Oh,
So, oop,
my bad.
that's okay. Here, let me pause this real quick. That's our do now. That's our little bit of review from yesterday. So we are going to now start a new page of notes. So everybody go ahead and get either your notebook out or whatever you like to keep notes in. And yeah, feel free to get paper if you don't have any. Do whatever you got to do. So just in case your paper gets lost or something, I always like to label mine because I am known for losing things. So I'm going to call this my geometry unit 2 because that's what we're on. Triangles. This is still day 14. So day 14 continued. All right, we're going to talk about some special right triangles. So that's literally what I'm going to title this page, Special Right Triangles, because that's what we call them. These are some special cases. Special right triangles. And can somebody remind me what makes a right triangle a right triangle? How do we know it's a right triangle?
90
The
degrees.
box.
Yeah, one of the angles has to be 90 degrees. You'll see a box in an angle. Perfect. So I want you guys to start by taking a ruler and we are going to create a special right triangle. And I want you to make the first side, let's do, I'm going to use centimeters actually. We want it to be a little small. Let's make the first side here 5 centimeters, like this. And then the other leg of this triangle, or the bottom side, is also going to be about 5 centimeters. We want these to be the same length. Okay, I made it a little bit too big, but that's okay. It's not perfect. Once you've made your 2 5-centimeter sides, we're just going to connect the 2 legs and draw our hypotenuse in, just like this. So now that we have this triangle drawn, Let's see, a few more people still drawing. I'll give you guys a second. Okay, so where's our 90-degree angle?
On the left side.
Yeah, this bottom left side here. So we're going to start by drawing a little box there to show that it's 90. And then these two remaining angles are congruent. That means they have the same measure. They're both going to be 45 degrees. So we want to label that 45 degrees and 45 degrees. Okay. Now, I'm going to give you some special numbers to write in here. So the bottom side and the side on the left, both of these we're going to label with an X, like this. Okay. And then our hypotenuse, we're going to label that with X, and we call this radical 2. When we have a number under a square root, we call that a radical number. So X radical 2. And all that really means is X times the square root of 2. That's all it means. X times the square root of 2. So this type of triangle we call a 45, 45, 90. It's a 45, 45, 90 triangle. And this is all going to make much more sense when I show you how we use these. Here's our first triangle. Now we're going to draw one more beside it, and this one's going to be slightly different. Take your ruler again, and this time I want you to draw a line for the first leg that measures about 6 centimeters. Again, it doesn't have to be perfect. And then we're going to make the bottom side right here, the other leg, make that about 4-ish. Let's make it 4 centimeters. Maybe 4.5, somewhere in there. And once you've drawn those two legs, we'll just connect them and draw the hypotenuse, just like the last one we did. And your measurements do not have to be exact to mine. It just has to be the base of the triangle needs to be shorter. The bottom side needs to be shorter. Okay. So once we got that, where's our 90-degree angle again? Same spot. Same spot. So we're going to draw our square just like that. And this time our angles are not congruent. They have different measures. So instead of drawing one arc on both of them, I'm going to put one arc at the top and 2 arcs on the bottom angle. This shows that they're not the same. And my smaller angle, the one at the top, this one's 30 degrees. Then my bottom angle, I'm going to ask you guys, if I have 30 degrees at the top, 90 degrees in my second angle, what would my missing angle be? How could we figure that out?
60.
60! How'd you do that? In your head?
All triangles have to equal 180.
Yeah, exactly. So if we just know that this should be 180 degrees total, well, I've already got 30. So if I do 180 minus 30, that's 150. Then I do 150 minus 90, that leaves me with 60. So we've got 60 degrees here. Okay. And we're going to also label our sides. The bottom, or the base, is going to be X. Then our hypotenuse, that longest side, is 2x. And our other leg, the side that goes up and down, that one is going to be x times radical 3. Okay. And we call this triangle a 30, 60, 90 because of the angles, 30, 60, 90. So 30, 60, 90. So once we've got those drawn, I'm going to show you how we use this. Okay. So I'm going to move my paper and I'm going to draw a little bitty triangle down here. Probably you can use your ruler again if you want, but I think I'm just going to make a rough sketch. Don't have to be perfect. I'm going to do a 45, 45, 90 triangle. So just needs to look like this. Now this time we're going to label our points of our triangle. This is just like with angles. Our angles meet at the vertex. Triangles have vertices, or this is a vertex. Vertices is just the plural. These points are called the vertices. We're going to name them A, B, and C, like that. Okay. So when we're looking at the length of sides of any shape, we name them by saying the letters of their end points. So if I wanted to name the hypotenuse, or this longer side here, I would call it AB. If I wanted to name the base or the bottom, I would name it BC. If I wanted this side, I could call it AC, or you could flip-flop the letters. Either way is fine. So I'm going to give you that CB, and to show that it's a line, we draw a line over it. So CB is equal to 3. Okay. So if I know that the length of this line here is 3, how could I use this, my x's and my x radical 2, how could I use that to find the length of the other sides?
So side A to C would be 3
Yeah, how'd you know that?
because it's like a key and gave us a key.
Okay, so what tells you that these two sides are going to be the same length? What about this picture tells you that?
Because there's 2 x's and then the other side's x squared.
Perfect.
Right.
So these are both x. They're the same letter. So we know that they are the same, x and x. So my x is 3. This side is also x, so AC must also be 3. So I'm going to write AC, and the other one I'm going to have to find is AB. And let's label them. So we just figured out that AC is 3. So we know that. How would we find AB? We know what
So
x is.
3 and then square root and then 2 inside the square root.
Yes, exactly. So if AB is x times radical 2, and we know what x is 3, we could just replace the x with a 3. It'll
Doesn't it
be-
turn to something else?
So we can keep it in that form, 3 radical 2, or we can solve it out and get a decimal, and I'll take either one. So 3 radical 2 is the length of this side. And here's how we would find the decimal. It's super easy. All you do is type in 3 radical 2, square root of 2, enter. That's my answer. That's it. It looks kind of scary, but it's really not bad,
How
guys.
did you type that in again? I'm sorry.
You're okay. I just typed in 3, and then I hit the second button, and I hit the x squared button where my square root is above it. See that?
Yeah.
And then I got my radical symbol or my square root. Those are the same thing. Those words are interchangeable there. So I've got 3 radical 2. And my answer would be, I could keep it as 3 radical 2, or I could say that it's 4.24. So there we go. Let's try another one like that. What if I give you another triangle like this? It'll be at 45, 45, 90. And this time, we'll call it D at the top, E at the right side, and F at the left side, like that. And what if I give you the length of DE? I'm going to give you the hypotenuse. I'm telling you that the hypotenuse is 7 radical 2. How would I find FE and DF? And again, it doesn't matter if I wrote FE or EF. Doesn't matter if I did DE or ED. As long as you have both of the endpoint letters under the line, then you're naming it just fine. I don't mind if they're not in the same order as mine.
Just do 7 bedrooms though?
Say it one more time.
Is 7 for both bedrooms?
Yeah, exactly. So I know 7 radical 2 is DE. I just told you that. And if I look up here, 7 radical 2 is the same thing as x radical 2. So if I know that these sides are x, because that's what my key tells me, I'm just going to look for what my x is. And my x is 7. You see that there, guys? Is anybody confused about how we know that x is 7 here? We got that? Awesome. So what is FE?
7.
7. What about DF?
Same thing.
Also 7. Good. That is wonderful. Okay, let's do some 30, 60, 90. So we're going to draw another little triangle. And this time we have a different number of arcs. Okay. So we'll name this one BC. And I'll give you guys a minute to draw that if you're wanting to draw it. give you AB 10. Remember, we're not doing the same key as the 45, 45, 90. Now we need to look at these numbers. So I want to find BC and AC. How would I do that? Hmm.
You have to do 10 divided by the square root of 2.
So you would if it was a 45, 45, 90, but we're looking at a different type of triangle here. So our hypotenuse of this type of triangle is just 2x, right?
Oh, okay, you have to divide by 2.
Yeah, we're just going to divide by 2 to figure out what our x is. Because I know 2x is the length of the hypotenuse, so 10 equals 2x. I think it might be helpful if we just label what the other lengths should be. We don't know the numbers yet, so let's just write the values, give ourselves the key again. We know the bottom is x. What's the other side?
X multiplied by square root 3.
Yes, x multiplied by the square root of 3. So Ritson, you're exactly right. We're going to start by solving for x, and to do that, we'll just divide by 2. So what is x?
20.
So that would be times 2. What if we divided by 2?
5.
5. Good. Do you understand why we're going to divide instead of multiply? If not, we can totally talk about it. I don't mind.
If you're taking away from the other side.
Yeah, it's like we're solving an equation. We really are solving an equation. 10 equals 2x. To get x by itself, we divide. So x equals 5. Now, which of my sides can be represented by x? BC or AC? Which of my sides, BC or AC, is represented by just x by itself?
See.
Yeah, BC. So what's the length of BC if we just found x? 5. We know x is 5. BC is x, so BC is 5. Okay. So we know x, we know BC. How on earth are we going to find AC?
I think for that one, you have to do 10 divided by square root 3.
So let's see. Why do you want to take 10 divided by the square root of 3?
Oh, wait, no, I did the wrong one.
That's okay.
5 divided by 3 thing.
Okay, so I'm going to ask you that again. Why do you want to divide by the square root of 3?
Because we're multiplying by each other.
Okay, so let's maybe write out the equation that you're thinking of in your head so I can understand what you're doing here. So you know that x equals 5, right? And we need to find what this answer is.
5. Square root of right equal 3.
So I think that what you're doing is you're just overcomplicating it just a teeny tiny bit. I think you're wanting to set up an equation in your head, which is actually what we're going to do next with a tougher one. But I think it's just a little bit simpler than you think it's going to be. So we know x is 5. So we're just going to plug it in to that. And we'll get 5 to this, or times the square root of 3. And that would be our answer. That makes sense, guys? Okay, awesome. So we can either write AC as 5 times the square root of 3, or what?
8.76.
Okay, 8.76. Yep, that sounds about right. 5 square root of 3. Ooh, I got 8.66.
Do you round it up?
So if you were going to round it up, you would be getting rid of the second or the third decimal. So it'd be 8.7, and then you just drop that other 6. But you got the rounding up part right. That's good. So we could say 8.66 or 8.7. Both are correct. And that's our answers. Okay. We got any questions about how to do this? We feel okay about it? You want to do one more together, or do you guys want to try some on your own now? We can do another together, but if you feel good, I can let you try it on your own.
You can try it on our.
You want to try it on your own? Anybody want to go through one more, or are you ready on your own?
Right.
Okay, let's do it. So, I've got some practice problems. Here's what I'm giving you. And here's what you need to find. So, anytime you see A, B, and C in the problems, we're looking at these here, the 30, 60, 90, because I labeled those with A, B, and C. So number 1 and 3, we're using the 30, 60, 90, okay? Number 2 and 4 are using different letters, D, E, and F. So we're going to be using the 45, 45, 90 here. So, like for number 1, I've given you the length of AB right here. AB is 2x. And I'm telling you that it's 12.
Are we going to turn this in?
This is our practice together. We'll have an exit ticket at the end. I'm not going to collect these, though. We're just going to talk about it. So I'm going to come around if any of you need help, okay? And I'm just going to pause the recording while you guys try these on your own. Okay, we set up 12 is equal to 2x, because that's AB. So we're going to solve for x. What did you guys do to solve for x? Exactly. Divide by 2, and we get x equals 6. Okay, so now that we know what x is, we just use that and plug it in for our other values. So if BC is x, what is BC? 6. If AC is x radical 3 and x is 6, what is AC?
6 radical.
Good, 6 radical 3. You could also make it into a decimal, but we'll just leave it like that for now. Let's look at number 2. This is one that was trickier. So this time, we're using a different triangle. We're using the 45, 45, 90. And I gave you the length of DE. It's 4. What is the key or the formula for that DE in this type of triangle? What's the X version of DE?
Would you put 4 radical 2?
Well, if it was 4 radical 2, that would mean x equals 4. But we don't know what EF is. EF is our x, or DF. We don't know those. We don't know x. So we got to solve for x. We do know that x radical 2 is equal to 4, right? Because those are labeled the same. DE is 4. DE is x radical 2. We follow in there? Okay, so why don't we set up an equation? What would that equation look like?
To get that right there, you'd have to do 4 divided by radical 2.
Okay, we are going to do that, but what equation would we set up? Because I think it's good to know why we're dividing by radical 2. It's good to be able to set that up.
X square root. Well,
Yes. 4 equals x times the square root of 2, or times radical 2. Now we'll do your step, Ritson, where we need to get x by itself. So since we're taking x times radical 2, we're just going to divide by radical 2 on both sides. Okay? And what happens to my radical 2's on this side?
Cancels out.
They cancel out. So now I have x by itself. X equals, what's 4 divided by the square root of 2?
4.
Yeah, 4 divided by the square root of 2. I've got 2.83. Do you think you typed it in differently? Maybe you hit times? Let's check. See what happens if I multiply instead.
you times it or divide?
You divide it. I just wanted to see where Ritson's number came from. I don't know what you just typed it wrong, you think? How did you do it instead?
I don't know.
That's okay. That is all right. We're all learning. This is brand new, guys. Okay, so we did 4 divided by radical 2, and what's our answer?
2.8.
Perfect. 2 we could say 8, and that's fine. That's our x value for number 2. So now we know what x is. How are we going to find the remaining sides? Plug them in. Both of these sides are just x. So if I know what x is, I know what my sides are because they're the same. They're both x. So EF is what? Perfect, 2.8. What about DF? Same thing, 2.8. Okay. Do we have any questions about that one before we move forward? Okay. Let's look at number 3. Okay, first of all, what kind of triangle are we looking at here?
30, 60, 90.
30, 60, 90. Thank you. So I gave you the side length for AC. Okay. So AC is over here. So what equation should I set up first?
6 equals 2x.
So that would be for AB. AB is 2x. What about AC?
Same thing, but you do 6 times.
You tricked us.
I tricked you. I did a little bit. Okay.
Do 6 times.
Here, let's set the equation up and we'll figure it out together. I know that AC is 6, and I know that AC is x radical 3. So I know 6 equals x radical 3. So let's write that out first. X radical 3 equals 6. So how do I solve for x?
6 divided by radical 3.
Yes, we need to divide both sides by radical 3 so that we can get x by itself. Okay, so those will cancel. And that will leave me with x equals, let's type that in and find out. 6 divided by
3.4.
3.4. That's what I got. Unless we round it up, then we'd have 3.5. You guys tell me if you're getting something different or if you're getting the same thing. I'm just going to write 3.46. Where do I go from here? Found X. How am I going to find my remaining sides? I need BC and I need AB. Left this over here. Make it a little easier. I know X. Here, that's better.
So would you put 2 and then in parentheses put 3.46?
Yes, we're just going to plug our X in to the values we don't know. We know AB is 2X. So I'm going to write AB is 2X. And I know what X is. X is 3.46. So let's put that in for X. 3.46. So what's 2 times 3.46? What's that answer, guys?
0.92.
Perfect. 6.92. So where am I writing 6.92? Which side? AB. Thank you. AB is 6.92. What do I have left to solve?
And then BC is 3.4. Sorry, I couldn't hear
Yes,
you.
you're okay. You're okay. BC is just X. BC is X. So we already know that X is 3.46. So I'm just going to write that in for BC. 3.46. There you go. Okay. Last one. Now we're using this 45, 45, 90. I know that EF is 25. This will be the easiest one probably. Ritson, I just realized when I looked at your paper, I told you wrong.
I got a whole bunch of stuff wrong.
I told you wrong. I'm so sorry. I don't know why I thought that that was the right thing. I'm mixing my letters up, I guess. I need to look at it more slowly. That's my fault. Okay. EF is 25. And what you said, Cheyenne, that's perfect. EF is X. So I already know X is 25. So how do I find the other sides?
DF is 25 because it's the same, same length as.
Perfect. DF is also X. I know X is 25, so let's just call that one 25. Now how do I find DE?
Same thing. You can,
Nope, you go.
okay, it's 25 times square root 2.
Perfect. If X is 25, we just need to plug it in to that equation or that expression. We've got X times radical 2, 25 times radical 2. We could leave it like that or we could solve it out. 25 times square root of 2. I got 35.4. leave these answers for you if you need them. And I'm going to put your exit ticket up. This is due next week. Today's Tuesday, so it'll be due by next Tuesday. It's the same problems we just did, using the same triangles. It'll be on Google Classroom, but this is your exit ticket. Just 2 questions. All right, in that, I'm gonna get it posted.